Welcome to room 206 at James R. Lowell Elementary School.
Over the last 6 weeks, our 4th grade classroom has grown from 30 students to 36.
These 36 students transformed into scientists every Wednesday in order to conduct experiments related to the water cycle and draw conclusions about it.
You're probably wondering, how did 2 LaSalle University students teach a room full of 36 4th graders with differing reading levels, abilities, and interests?
Our unit would not have been possible without the application of several theories and instructional approaches.
Let us take you on our journey through the water cycle.
One of the theories we apply throughout our unit is constructivism. This is a theory that states people construct their own understanding and knowledge of the world through experiencing things and reflecting on those experiences. When we encounter something new, we have to reconcile it with our previous ideas and experiences, maybe changing what we believe, or maybe discarding the new information as irrelevant. In any case, we are active creators of our own knowledge, and to do this, we must ask questions, explore, and assess what we know. In this approach, the teacher became the facilitator, and the learners are responsible for constructing their own knowledge. In our unit, this approach was used in every lesson via the 5E instructional model. Students were responsible for exploring each topic in their small groups by first making a hypothesis, then making observations, and finally drawing a conclusion. As the students went through this process, they were able to discard any misconceptions they had before starting. In lesson number 1, students explored the 3 phases of matter by creating a cloud in a jar. We activated their prior knowledge about solids, liquids, and gases by having the students stand up and act as the particles of each. They stood relatively still to represent a solid, swayed back and forth to represent a liquid, and moved quickly in place to represent a gas. After this, students transformed into scientists and used their lab reports and followed the instructions to create a cloud in a jar. In doing so, the scientists observed all 3 phases of matter and constructed their own understanding of each through hypotheses, experimentation, and observations. Piaget's theory of cognitive development goes hand in hand with constructivism in that they both call for hands-on and minds-on learning. This theory states that the students in our classroom are at the concrete operational stage, which occurs between the ages of 7 and 11 years old. During this stage, thinking becomes more mature and logical, but students can only apply this type of thinking to concrete real-life events. The water cycle is a rather abstract concept, but by breaking it down and making it more concrete through experiments, the scientists were able to learn it with ease.
Another theory that was applied in our science unit was the information processing theory. The overall idea of information processing theory is that the human brain is like a computer that takes in information and responds to it. Once the information is given in a designated environment, it is gathered via the senses through a process called transduction. In order for this information to stay, it must be rehearsed and repeated. The information learned becomes declarative knowledge, which helps them recall important facts, or procedural knowledge, which can assist them when performing experiments. In this approach, the teacher allowed the students to take in the information through different senses in the variety of experiments conducted throughout the unit. Specifically, in Lesson 3, students explored precipitation by experimenting with shaving cream and blue-colored water to represent rain. The repetition of the water cycle concepts through experiments allowed students to conceptualize the information about the water cycle and express the information in their own words. Another theory that we used was Vygotsky's theory of cognitive development. He expressed how students learn through social interaction. He states that learning is an essential part of developing culturally as well as organizationally with human psychological functions. He also places emphasis on the role of language with cognitive development and how students can benefit from social learning. We use Vygotsky's theory through having the students work in their table groups assigned by the cooperating teacher. By learning from each other and working together, they are expanding their zone of proximal development through the interaction with other students that are on different academic levels. The students created a dance to the water cycle song, which allowed them to work together as a class in order to remember the components of the water cycle. This dance allowed for social interaction with classmates and created the sense of community within the classroom.
Finally, Erikson's theory of psychosocial development places our 4th graders in the industry versus inferiority stage. This is when problems of inadequacy, inferiority, and low self-esteem arise. In room 206, we battled these issues by giving specific praise to students each time they did individual or group work. We also encourage students to share their work with their peers so they feel a sense of industry. One specific example of this occurred in Lesson 5. Students constructed a narrative about traveling through the water cycle as a drop of water. At the end of the lesson, we allowed students to stand up and read their final pieces. One student who shared, Messi, reads at a first grade level and tends to be behind his classmates. After sharing his work and hearing his peers applaud him, he was very proud of himself and the work he had done.
Thank you for joining us on our journey through the water cycle. We would like to extend our greatest thanks to Mr. Dempsey for allowing us to be part of his classroom this semester. He had provided us with great advice and tremendous insight into what it is like to be a 4th grade teacher at Lowell Elementary.
These wonderful 36 students have taught us more over the last several weeks than we could have hoped for. Most importantly, our students taught us how the theories we learned come into life in the classroom through hands-on learning, positive reinforcement, making connections, and social interaction.
Through this experience, we have learned so much about each other and how to work as a team. In our future teaching careers, we will always look back at our time together at Lowell and appreciate having this priceless opportunity.
While our time in room 206 at James R. Lowell Elementary School may have come to an end, the memories and knowledge we have gained will never leave us.